Today we're going to start our final chapter, Chapter 9. What we're going to do in Chapter 9 is we're going to do something similar to things that we've seen in previous chapters, but instead of focusing on population proportions, we're going to be focusing on means. So in Section 9.1, we're going to talk about sample means of random samples. So in Chapters 7 and 8, we learned two important techniques for statistical inference, the confidence interval and the hypothesis test. In those chapters, we applied the statistical inference for population proportions. In this chapter, we will use the same two techniques for making inferences about the means of populations. We will begin by taking a closer look at sample means. So again, instead of focusing on proportions, what we're focusing on in Chapter 9 is means. Right? So what we see in this table here is just a brief review of some notation. So when we're looking at our statistics or our parameters, we use different notation for each one. Remember, a statistic is a sample and a parameter is for a population. So our sample mean is represented by x bar, our population mean is by mu. Sample standard deviation is S, our population standard deviation is sigma. Sample variance, which we talked briefly about, was S squared. Population variance is sigma squared. A sample proportion, p hat. Our population proportion, p. So the S squared and the sigma squared we don't see too often. Again, we briefly kind of touched on these previously, but we're not going to focus in on them too much. Our sample proportions and population proportions, again, have been our focus of the last two chapters. So what we're going to be looking at in the notation that we're going to use a lot in this final chapter is our sample mean x bar versus our population mean mu, and our sample standard deviation represented by S, and our population standard deviation represented by the Greek letter sigma.